Now let's revise on Macaulay duration. Now this unit you find it in fixed income investments analysis as well as advanced financial management. Now Macaulay duration, you look at the meaning of Macaulay duration as well as modified duration. Now the definition we have there from our illustration, because I want us to look at this question that you can see down here, because my interest today is on the calculation part of it. You can see some explanations here where you are told that Macaulay duration calculates the weighted average term to maturity of a security's cash flows. That's the meaning of Macaulay duration. That is, it calculates the weighted average term to maturity. That is called YTM of a security's cash flows. An example here. So our example starts from here. Assume a bond with 3 years remaining to maturity, bearing a 5% coupon rate, paid annually with a 10% yield to maturity. Now I've said here, because in this illustration we are not given the par value of this particular bond, so we assume that the par value is shillings 1,000. So calculate the Macaulay duration. Now Macaulay duration is like computing what you refer to as payback period. In financial management, because you have done investment appraisal techniques such as internal rate of return, the discounted payback period, the payback period, maybe the net present value, accounting rate of return, among other investment appraisal techniques. Here, the Macaulay duration is the same as, is similar to the payback period. What do you mean by payback period? With respect to investment appraisal techniques, is at the time that it takes for a project to recoup the initial capital outlay. Now, having that in mind, let's come back to the Macaulay duration. Now, if you are given this analysis here, that this particular bond has 3 years remaining to maturity, so our calculation entails a column here for year 1, 2, 3, because there are 3 years to maturity for this particular bond. Then payment here. Now, what we mean by these payments here is that in the first year, you will pay now 10%, but the coupon rate is 5%. What are we supposed to pay per year for this bond? Remember, a bond is like a debenture or a loan. So if you get a loan, you incur interest as the expense. So if the par value is 1,000 shillings, the first year you pay 5% of 1,000. 5% of 1,000, assuming the par value or the face value of that particular bond is 1,000. So 5% times 1,000, first year you pay 50, second year you pay the same 50, 5% of 1,000, 50. Then because this particular bond matures in 3 years, in the third year you will pay 50 again plus the par value, the entire figure. Now you combine the two, that is the 1,000 par value you plus this particular payment which you are making per year. So you can see in the third year, the total payment will be the face value of 1,000 plus 50, 1050. That is the first, the second column. That's how you get these numbers here. The second or the third column, you calculate the present value. The present value, you usually take the amount divided by 1 plus rate raised to t. Now, the rate here, the YTM is 10%. So you are taking this 50 divided by 1 plus 10%. In other words, 1 plus 0.1 raised to t. T is 1 here. So the first here will be 50 over 1.1 raised to 1. You get 45.5. Then the second year, you take 50, this amount, over 1.1 raised to 2. The only thing changing here is 2 because we're in the second year. And the present value will be 41.32. The last, number 3, what is changing here? The amount now will be 1050. We have explained how we are getting 1050 divided by 1.1 raised to 3. The 3 years here, 3. And you get 788.9. You sum up of this, you get 875.7. Now this figure is a value of this particular bond, but the last column here, because for us to calculate the MACAULAY duration, we need the totals on this last column. So to get these figures here, we are supposed to pick the present value times time. Very straightforward. So you'll be taking 45.5, that is the present value for year 1, times 1, that's the first year. You get 45.5. Second one, 41.3, just this figure which is here, multiplied by 2. 2 is the second year. The second year here, you get 82.6. The third year is 788.9. You multiply by 3. 3, we are in the third year. You get 2,366.7. And all this, you get 2,494.8. Now, MACAULAY duration, you just take the totals for this column, that is 2,494.8 divided by 875.7. And you get your MACAULAY duration is 2.85 years. If you divide this amount by this amount, which has been calculated down here, the MACAULAY duration will be 2.85 years. So what is the meaning of this? It means that the nominal value, that's not the meaning, but it means that it will take 2.85 years to recap the initial amount that you have invested in that particular bond. A small note here, the nominal value is assumed to be shillings 1,000. That's something that we entered here. We have assumed the nominal value of this bond is 1,000. Thus, the dividends received will be 5% times 1,000, which is shillings 50. That's how we are getting these figures here in the second column. However, upon maturity, the investor will receive shillings 1050. This figure here in the third year. That is the initial investment, you plus the dividend for that particular year. But let me rectify here. These are not dividends, because dividends, we receive dividends where we have shares, like ordinary shares, preference shares, and any other type of share. So here we are not dealing with shares. So just a small correction there. These are not dividends. The 50 is not a dividend. This is interest. Because as I've mentioned earlier, a bond is like a debenture or a loan. Collectively, we refer to them as debts. A debt comprises of either bond, loans, or debentures. So in all those three, what we pay is interest. So these are interest, these are the 50-50, that is interest that we are paying based on the coupon rate of 5%. So this is not a dividend. 50 is not a dividend, is interest. But that is not affecting our calculations. Right, so I've shown you how to calculate the Macaulay duration. Very simple. You just pick the coupon rate. Sometimes these percentages do confuse some students. The 5% coupon rate, and then we have 10% yield to maturity, YTM. So to calculate the interest that you are paying, you use the coupon rate. Don't use the YTM. YTM is used here. We divide by this. When you are calculating the present values, that is where you use the YTM. But to calculate the amount paid or received, you use a coupon rate. Note that one. Coupon rate, you multiply by the par value. The other name for par value is a face value or nominal value. All right, so I think we are okay with calculation for Macaulay duration. Another important concept is how do we calculate modified duration. Modified duration. For you to calculate modified duration, you must calculate Macaulay duration. You cannot calculate modified duration without first calculating the Macaulay duration. As you can see in my formula here, is Macaulay duration over 1 plus, into brackets, yield over n. Now before that, important note here about modified duration. Modified duration is the approximate percentage change in a bond's price for 100 basis point change in yield, assuming that the bond's expected cash flows do not change. Using the above example, the modified duration will be computed as follows. Note our Macaulay duration is 8.85 as calculated above here. I think that one is very clear here, the calculation of Macaulay duration. But here we are saying modified duration. It tells us if the price or if the price of a bond changes, what is the relationship between the change in the interest rate and the price of the bond. If the interest rate changes, for example, from 10% to 11%, how will the price of the bond change? So that relationship between the change in the interest rate and how the price of the bond responds to that particular change. So the modified duration helps us to know the relationship between the two, change in interest rate and the change in price of the bond. The formula is here. The numerator, we do not have any problem with the numerator as long as we have known how to calculate the Macaulay duration. We just need to mention something very small here about the denominator. 1 is just 1 plus y, not so YTM, but the yield divided by n. So you need to know what is n. Now before we turn to the next page, I just want to mention that this is a fixed income investment analysis study text. I believe you have the book. You have fixed income investments analysis, CIFA, Certified Investments and Financial Analysts. We are looking at an example from page 114. For those who have the book, I think you are there. Now, we have just explained the concept of Macaulay duration we are now tackling modified duration. I want us to move to page 115, and you can see on that side that is N. What's the meaning of N? N is a coupon per year. How many times do you pay coupon? We are told this payment is made once per year. Thus, the yield over N means what? Yield 10%. That is a YTM, 10% over 1. The interest is paid once per year. Because you can have payments being made semi-annually or quarterly or maybe on monthly basis. But in this case, the interest is being paid once per year. So our N is 1. So that's the yield over N is 10% over 1, which means 10% is the same as 0.1 over 1, which is 0.1. Thus, our denominator will be 1 plus 0.1 because this part is giving us 0.1. So just 1 plus 0.1, which is 1.1. So our modified duration. So our denominator, you can see it translates to 1.1. Our modified duration will be 2.85. Remember, 2.85 is the MACAULAY duration divided by the denominator, 1.1. That translates to 2.58%. Remember what we have said about the meaning of modified duration. It helps us to understand or to know the relationship between the change in interest rate with the price. If the interest rate of a bond changes, how will the price respond? How will it change? Let's mention a simple point explained down here. The following formula can be used to estimate the percentage change in a bond's price. Percentage change is equals to minus modified duration times change in yield times 100. Now, I think this is not very important is that this is change, because already we have our answer here is 1.295%, which we got here is 2.59%, this particular portion, because our focus for this lesson was calculating the MACAULAY duration and modified duration. So we just need to understand up to this level here, but you can still try to analyze this particular portion because of time, and that is for those who have our study text. That is page 115, fixed income investments analysis. Now we are through with that particular question. Remember, what we are trying to discuss today was how to calculate or the use of MACAULAY duration and the use of modified duration. Now, the last example that I want us to take from the same topic, we can go to page 120. Can go to page 120, the same book, page 120. Page 120. There is a good question here for you, but we can do it together. This question here, Tausi Limited issued a term bond with a face value of shillings 1,000. I've told you the face value is the same as par value or nominal value. You want to calculate the interest, then you just take the coupon rate times this particular amount here, the face value. So don't confuse don't confuse between the YTM and the coupon rate. to calculate the interest that we are paying, we multiply the coupon rate times 1,000. In our case here, you'll be using 12% because 12% is a coupon rate times 1,000. Then you'll be dividing by 1 plus rate. Rate is a YTM, the yield to maturity. Back to the question, and then you can see it is in page 120. So as I read the question, you can just write it somewhere because I'll be moving to the next page, page 121. So you're told Taus Limited issued a term bond with a face value of shillings 1,000. The yield to maturity, that is YTM, of the bond is 10%, and it has a coupon rate of 12% per annum. The bond coupon will be paid annually. The term bond to maturity is 4 years. Required. Move to the next page. Required. So using that particular information, which we have read from the other side, we are supposed to calculate the price of the bond. Number 2, the MACAULAY duration. Number 3, the modified duration. And number 4, the bond convexity. Let's start with the MACAULAY duration. Because you have done the MACAULAY duration, I don't expect any challenge from your side. You have just done it from the other page. You start with how much are we receiving? You take 1,000 because 1,000 is the face value of the bond times 12% is a coupon rate. So 12% times 1,000 is 120. Remember, these payments are being made per year. They are being made per year. So the bond matures in 4 years. So you have a column here for year 1, 2, 3, 4. The payments here, year 1, you receive or you pay 120. This 120 here. Year 2, you pay 120. Year 4, you pay 120. But year 4, you pay 120 plus 1,000, the face value. The face value was 1,000, and you plus 120. So the payments will be 1,120. Those are the payments, this particular column, just as we have done with the previous example. The present values, you use the same concept. 120 divided by 1.1. Now 1.1 means, because it's 1 plus YTM, it's the same. YTM was 10%, it's 10%. If you look at our question, you're saying 1 plus 0.1 raised to 1, year 1. That is year 1. This is year 2, year 3, year 4. So what is changing here is only the number of years. And then here, year 4, because this bond matures in 4 years, in the 4th year, there will be cash flow of 120, and then the other cash flow is coming from the face value, the 1,000. So 1,120 divided by 1.1 raised to 4, year 4. And you'll be able to get these numbers here. And all of them to get 1063.4. Usually, this number here, if you add the present values, this represents the price of the bond. The price of the bond. The price of the bond is 1063.4. So by so doing, we have answered part 1. The price of the bond means the present values of these cash flows for the 4 years. Then we continue, because for us to calculate the MACAULAY duration, we need to calculate or we need to have the last column here, whereby you take the present value times the respective years. The first number here is 109 times 1, because we are in year 1, you get 109. 99.2, this figure here, times 2, we are in the year 2, you get 198.4. Year 3, 90.2 times 3, you're in the year 3, you get 270.6. And then year 4, 765 times 4, we're in the year 4, you get 1360. You add all these numbers, you get 3,638. So this number here, you divide by this number here to get MACAULAY duration. Very simple. So the MACAULAY duration, if you divide that 638, this number here, divided by the total present value, 1063.4, you get 3.42. This means that it will take 3.42 years to recap the true cost of the bond. Away from that, so we have answered number 1. The price of the bond, we have gotten 1063.4. The MACAULAY duration, 3.42 years. Then the modified duration, just as we have done with the previous question, the formula is here. You cannot calculate the modified duration without first calculating the MACAULAY duration. So the MACAULAY duration we have computed above is 3.42. We need the denominator, that is 1 plus YTM over N. N, the number of payments per year. We have been told that payments are being made once per year. The YTM is 10%. So we just need to take 1 plus 0.1 over 1. So N is the number of coupon periods per year. In this case, our N is 1, since coupons are paid annually. Now, let's calculate our modified duration. And we have explained what we are interested with whenever we are calculating the modified duration. We want to see the relationship between the price and the interest rate. If the interest rate changes, how will the price of the bond respond? So, 3.42 is the MACAULAY duration divided by 1 plus YTM. The yield to maturity is 10%, so 0.1 over N. Payments are being made once per year. So if you work out that is 3.42 over 1.1, you get 3.1%. What does that one mean? This means that for every 1% movement in interest rate, the bond would inversely move in price by 3%. That's the meaning for that. The last portion for that question is convexity. Now, convexity, I think yesterday we did the theory for convexity. We know the meaning of convexity. We know how it applies. But let's just show how it is calculated. How do we calculate convexity? Now, we just need to add a column here. The other part here is just like the first table here. So you have a table whereby the first column we have time. Remember, this bond matures in 4 years. So time 1, 2, 3, 4, 4 years. We are doing convexity because the last question is the bond convexity. That is question number 4. Is what we are calculating. So just have a column for time 1, 2, 3, 4. Cash flows are the same. First year 120, second year 120, third year 120, fourth year 1120. Because the fourth year you receive 120. Remember, 120 is 12% of 1,000. 120, 120, 120, and then 120 plus 1,000. 1,000 was the face value. So in the fourth year, the cash flows will comprise of 2 elements. That is 120 plus 1,000. The present value, the next column here, will comprise of the present values. So just pick these figures from here. 109, 99.2, 90.2, 765. These figures here. These are the present values. These are the present values. Just bring them here. Then weight. The other column now, this one we do not have. Weight, we don't have the weight. But how do you calculate weight? From the previous table, when calculating the MACAULAY duration and the modified duration, we don't have the column for weight. But weight, you take the present value divided by the price. Now, how do we get 0.1025? We took the present value 109 divided by price. I think the price of the board we have gotten here 1063.4. I think I should confirm that. I should confirm that whether it is the right thing that we are doing. Now let me just take the first one, because we are taking 109. We are taking 109 divided by, we are dividing by 1063. 1063.4. What do you get? 0.1025. So this number here. So that is how we are calculating. What about the second one? Is this number correct? This weight for the second year, what are we supposed to take? Now take 99.2 and divide by 1063. I divide by 1063. 1063.4. What do you get here? 0.0933. And so that is how we are calculating those figures here. The weight. So the weight here, when you are calculating convexity, you have a column for weight. So just be picking the present value, these numbers here, for each year separately, divided by the price. The price we have said, price of the bond means the total present value, which are here. These are the total present values. So that is how we got these ones. Then the last section, this is the most important, because the total sum is what will be helping us to know our convexity. Now let's see. T times into brackets 1 plus T, close the brackets, times weight times 1 over into brackets 1 plus YTM. Now note this. This part here is just one number. You just calculate one number here. So this part remains constant. This part will be just one number. Now let's see, what is T? What is T? And what is 1 plus T? And what is weight? Already we have your weight somewhere. You have our weight. Weight, we have the weight here. So what do we need? If I calculate this particular section, it will be a constant number because I'll be taking 1 over 1 plus 0.1 squared, because YTM is 10%. So this section here, you can just have one number here. This part here. Because it is 1, this part is 1 over 1 plus 10% squared, your one number. Weight, we have the weight. The numbers are here. We have our weights here. T, I'll show you what is T and then what is 1 plus T. We have just illustrated here. It's not complicated. Now the price of the bond, remember we have said is 1063.4. It's the price of the bond. If you earned all these numbers here, they'll give you the price of the bond. The total sum in the fifth column gives us the convexity. So for us to get the convexity, we need to substitute our numbers in this particular formula which you have here. That is T times into brackets 1 plus T multiplied by weight times 1 over 1 plus yield to maturity squared. Now let's see what you have said down here. The first T means 1, 2, 3, and 4. This T here, the first T here, is just time. Simply T means time, which you have here. Then 1 plus T means 1 plus time. So here we'll just be saying, if you're in the first year, you take 1 plus 1. Year 2, 1 plus 2. Year 3, 1 plus 3. Year 4, 1 plus 4. Weight has been computed as a present value of the price of 1063.4. So you have 1063.4, which is here, which is a price. The remaining part is a constant value of 0.8264, computed as follows. This number I've said is a constant figure. It's not changing at all. This portion here is a constant figure. This is how we have calculated that. 1 over 1.1 means 1 plus 0.1. Because YTM, the yield to maturity was 10%. So 1 plus 10% squared, the answer then is 1 over this particular portion here. You get 0.8264. So this portion is constant. Now you have said, for instance, in the fourth year, how did we compute 11.89? How did we get this one? We are using fourth year because it's just a matter of substituting these numbers correctly. So we have used year 4 to show you how we calculated 11.89. So you see what you have said here is T times into brackets 1 plus T times weight times 1 over into brackets 1 plus YTM squared. See, we have said T means time. So this 4 here is, we are in the fourth year. 4 times 1 plus T. 1 plus T. This T here is, we are in the fourth year. So 1 plus 4, because we're in the fourth year, times weight 0.7193, which is here 0.7193 is the weight, multiplied by this last portion here, and you have said it is always a constant number. It will not change regardless of which time you are dealing with. If you work out that, then you get 11.89. If you are to do part 3, year 3, what could you have done? Time 3, how will you get 0.84? Yeah, that is year 3. You take 3 times 1 plus 3 times weight, year 3 is here, times 0.0848, and then you multiply by 0.8264. This portion does not change. Year 2, you take 2 times into brackets 1 plus 2 multiplied by 0.0933 times 0.8264. If it is year 1, how will you get that for year 1? It will be 1 times into brackets 1 plus 1 times 0.1025 times 0.8264. You get 0.17. So basically that is how we calculate the MACAULAY duration, the modified duration, the convexity, and the price of the bond. So to get the convexity, lastly, you get the sum of this, what you have in the last column here. You sum up all of them, and if you add all of them, you get 13.36. 13.36 is our convexity. So that is the solution for that. That is how we go about that particular calculation. I think we are able to understand everything. Everything is in perspective. Everything is in perspective. We have been able to calculate the price of the bond. We have said to calculate the price of the bond, what you do is that you calculate the present values of these payments, and we have explained how we are calculating those payments there. We are taking the face value or the nominal value of the bond, which is 1,000, times coupon rate 12%, you get 120. So year one, you pay 120. Year two, you pay 120. Year three, you pay 120. But year four, you pay 1120. Then present values, you just take these cash flows here divided by 1 plus YTM. 1 plus YTM is yield to maturity, which is 10%. So 0.1. 1 plus 0.1 is 1.1 raised to T. T now is the number of years as given here. And remember to change the T as time goes on. T has to change as time goes on. The payment or the payments that you make in the last year will be different because it will be comprising of the interest paid that particular year plus the face value of the particular bond. And then you sum up all this, you get the price of the bond. The price of the bond simply means the present values of those particular bonds. Then the last column here, you just take the present value times the time, 1, 2, 3, 4. You multiply by the time, you add all of them together. Then to get the MACAULAY duration, multiply this, not multiply, but you divide this figure by that figure. Whatever you get is the MACAULAY duration. So MACAULAY duration means, as I have mentioned earlier, it is the same as the payback period. As you apply that concept in investment appraisal techniques. Modified duration, we have shown you how you go about it. You just need to concentrate on the denominator because you have calculated the MACAULAY duration. And we have said that modified duration will help you to understand the relationship between interest rate and the price of bond. When the interest rate changes, how will the price change? And then the last part is convexity. And that one we have said the most important columns are the last two, which you earned here. The first three, you have them with that table where you are calculating the MACAULAY duration. And the third or the fourth column here, you just need to calculate the weight. The weight, you just take the present values, which you have calculated divided by the price of the bond. The total present values here gives us the price of the bond. You divide by that to get this. And then we have just shown how to arrive at these numbers. You can just look at the explanations we have down here. Even though I have written a lot of other things on top of the numbers, I don't know whether you are able to see the numbers clearly, but I think as I was writing on them, I was still explaining, so you know what has happened here. It looks like a forest, but I still think it is legible. I think the formula is there still here is clear, so that is how we are calculating these numbers. You hand all of them to get the convexity. Now let's bring our discussion to an end at that point. And we have discussed about the price of the bond, the MACAULAY duration, the modified duration, and the bond convexity. Now if you are taking CIFA, certified investments and financial analysis, that concept or what you have done is very important. Specifically, those who are taking fixed income investments analysis, and also those who are taking advanced financial management, that is CPA, quite important concepts. I think what you have discussed to be very helpful as far as your examinations are concerned. So we bring our class to an end. My name is Mr. William, Center for CIFA Studies. My numbers are just down there, 0727 87 10 93, 0727 87 10 93. You can still purchase our books where you can have more revision concerning these concepts, among others, either study texts or the revision kits. You can still subscribe to our YouTube channel so that you may be receiving these lessons whenever we post our lessons in our YouTube channel. You can still get us through our contacts for classes or any other assistance that you may need wherever you are, whether you are within the country or you are in other countries. We can still be available to assist you through the online classes. So let's meet tomorrow, where we will be discussing different concepts as far as investments are concerned. Thank you.